Hello there, welcome to another tutorial with my lab with Lucy. Today we will be doing ELISA results interpretation. ELISA is an immunoassay and I have put a card for the ELISA overview that forms the basis for this lesson today. So if you haven't checked out the ELISA assay overview, kindly check it out and then come watch how we now do results interpretation. So the results interpretation can be in two categories: qualitative results as well as quantitative results. So for qualitative, we are going to be checking a kit that has been done by Murex for HIV antigen antibody combination testing. And usually in qualitative, that gives us two results, that this is reactive or this is not reactive. Usually the kit will define how we calculate the cutoff point of determining reactive versus non-reactive. So in the Murex, which is an enzyme immunoassay for improved detection of seroconversion in human immunodeficiency viruses type 1, here, and the detection of anti-HIV2 antibodies. This assay is supposed to screen individual human donors for the presence of 1, the P24, and then antibodies against HIV1 and antibodies against HIV2. So in this Murex antigen antibody combination, we usually will have our microtiter well, this one, coated with HIV1 antigen, HIV2 antigen, and P24, which is a co-protein of HIV virus antibody. And now in the patient serum, we are targeting the antibodies, okay, against HIV1 and antibodies against HIV2. We are also targeting antigen, which is now called the P24 antigen. And then on these ones, then we raise now enzyme conjugated antibodies for detection. And these enzyme conjugated antibodies are going to bind to the primary antibodies that are coming from the patient, as well as the antigen that is coming from the patient, that is of P24. So in this situation here, it is a combined ELISA technique, and we have already looked at the different types of ELISA. I will place a card again up here for you to refer. And we talked about four main types of ELISA. We had direct, okay, we had indirect, and then we had sandwich, and then we had competitive. Now in this case, being a combination, we are having two methods or two types. This one is indirect ELISA, and this is sandwich ELISA. So now we did this test, and here is a microtiter plate of the samples that we carried out together with the controls. So for the sample arrangement on our plate, we have this well 1 here, and well 2 contains our controls, and then from this well here downwards up to the end contains our patient samples 1 to 6. Now on the controls, we have now positive control 1 in this well here. Then we have positive control 2. Then we have positive control 3, which is P24. And then we have the negative control. And the same here, because we have done them in duplicate. So this is positive control 1. This is positive control 2. This is positive control 2. This is positive control 3. And this is negative control. Okay. So that is the arrangement of our samples as well as our controls. And for all the positive tests, we get an orange color. This is after adding the stop solution. And for all this is for positive. For all the negative tests, we get a pink color. Okay. So now once you have obtained these results, from just visualizing, because it's a chromogenic reaction, you can actually tell the results. For example, we can see that here, this is our positive control 1, and also this positive control 1, and we can see that they're actually positive. We have positive control 2, and they are positive. Positive control 3, and they are positive because they are orange. And then we have negative control and another negative control because they're in duplicates, and you can see that they are pinkish, and that means they're negative. And now for our samples, we can tell that this sample 1 is negative, sample 2 is positive, sample 3 is negative, 4 is negative, 5 is negative, and then 6 is positive. So already we can, kind of give results, but usually now we will determine the cutoff point by reading optical densities of these colored products using a spectrophotometer or an ELISA reader. And this is how now we determine the cutoff point and calculate the results. For this particular assay, we will pick the negative control absorbances, and we have said we did this in duplicates. So what we do is that the negative control, we get the mean. Okay, so we obtain the mean. Let me use a highlighter. We obtain the mean, okay, of our controls. And once we have gotten the mean, then we are going to calculate the cutoff value. And in this case, we are adding 0.15 to the mean of the negative control replicates. And for this example here, the mean control was 0.080, and they added 0.15, and they got this as the cutoff point. So that any non-reactive test is the cut at the below this cutoff, and any reactive test is equal to or above this cutoff point. In our case, we read the results using spectrophotometry or the ELISA reader at 450 nanometers, and these are the results that we obtained. And you can see that these first two rows were the controls, and the subsequent rows were the patient samples up to sample number 6. So these are the optical densities that we have obtained. And as we have mentioned, for this kit, we need to develop the cutoff point by getting the mean of our negative controls. So these highlighted here are our two negative controls. So we calculate our cutoff point by adding the two, that is 0.176 and 0.155, and obtaining the mean, and then the mean is 0.166, and to the mean we add 0.15. After that, we now obtained 0.316 as our cutoff point. Now that means that any value less than 0.316 is negative, and any value above and equal to 0.316 is positive. So we can see from here the values that are above. This is above 0.316. These are also, all of them are above, and then these all of them are above. Okay, so all those are positive, and our negatives are, of course, the negative controls, then sample 1, patient sample 3, sample 4, sample 5. Okay, and that can be confirmed with what we already saw in our previous results here, that all these are negatives, that one, that one, that one, that one, and then the ones that are positive, including our controls, are these ones, this one, this one, this one, and this one. For quantitative results interpretation, we develop or generate standard curves, and these standard curves we use standards that have known concentration, and here is an illustration of how we make the standards dilution, and then from there we plot the standard curve, that is optical density at 450 nanometers and standard concentration on the x-axis. Now, once it comes to the analyte, we will also now read optical density at 450 nanometers and extrapolate from the graph here. For example, if we had optical density of 1, we are going to extrapolate this way, and this is going now to give us our analyte concentration, if it is the antigens, if it is the antibodies that we were investigating. That is all for today. If there's any questions, kindly post them at the comment section, and see you in our next lesson.